Hello, today I'm going to be doing a tutorial on recursion. So to get started, I'm going to give you a simple analogy to explain it. So if you've heard of a for loop, a recursion is basically just that. In this scenario, we have Aladdin, and he finds this lamp, he rubs it, and a genie comes. So let's say that the genie asks Aladdin for one wish. What would happen if Aladdin keeps asking for more one wishes? So he says, I wish for one more wish. He says it again. He says it a third time. So what's happening here is Genie says, you get one wish. Aladdin says, I want one more. Genie asks again. He says one more. The genie asks again, and he says one more. Finally, Aladdin says, I want $1 million. Now, logically, this might not make any sense because he's only asking for one more wish. It would make more sense to ask for 2 or 3. But in this scenario, just understand that he's asking for one wish. So, I know it seems kind of redundant, but just trust me. So, in this case, we know that the genie is going to be represented as the function. This is because it is asking our user, which in this case is Aladdin, and also the parameters for what he wants. And then I actually model this as a function and encode right below. So here's our function, which is a genie, okay, right here. And then I state that the wish symbolizes the wish Aladdin wants. The count, right, symbolizes the amount of times Aladdin says one more wish, right? So in this case, up here, the count is 3 because it says one more wish, one more wish, one more wish 3 times. And then the final wish symbolizes the wish after the final count. Okay, so if count is 0, wish and final wish are the same. Basically, the wish, in this case, is his first wish. So let's say he says one more wish. All right, that's his wish. The final wish is what he says after, the last wish. It's the last wish. If count equals 0, which means that he didn't say one more wish at all, then the wish, the original wish, and the final wish are the same. Hopefully, that makes sense. So, if count is greater than 0, which means there is at least one more wish, right? In this example, the count is greater than 0 because there's 3 one more wishes, right? He asked 3 times for one more wish. That's what count represents. Count is negative equal to 1. This just says that the count value, which in this case we'll say is 3, okay, it subtracts 1 each time and equals 1 value less than it originally does. So to also make it comprehensible, and so we can see what's going on in our code, I wrote print one more wish. And finally, this is the part where the recursion actually happens. Okay. Basically, we have a return statement in our function that returns the final wish and counts. So, in this case, let's take our input here, for example. Our final wish is $1 million, and our count is 3. That means it's going to ask for one more wish 3 times, and then on the 4th wish, it's going to ask for $1 million. Okay? So what's going to happen is that count starts at 3, and since count is greater than 0, we're going to subtract 1 from the count. Then what we're going to do is we're going to print one more wish. That goes right here. And then we return the genie function with the final wish and the new value of count, which is now 3, subtract 1, which is 2. Okay, and this loops around. Then, once we return the function, and the function inside of it, right, it goes again. Since our count is 2, it goes, if count is greater than 2, which it is, count subtract equal 1. It prints one more wish. Then, it returns the value, which is 1 now, because you do 3, subtract 2, subtract 1. Now your count equals 1, and if count is greater than 0, which again it is, count subtract equal 1. Finally, you print one more wish, and then your count is now 0. Okay. Now what happens is that since count is 0, this code does not work anymore because count is greater than 0 now. So it's going to skip after the if statement to the final wish. And it's just going to print final wish and return true. The true statement just means was the wish granted. So that's a simple way of explaining recursion. And recursion is just making a loop inside of its function by returning the function inside of the function. Because here we define it, and then here we return the function inside of the function by changing the parameters, okay? You can't have recursion without changing the parameters. Also, a mistake that I also see when people do recursion is not returning. You can't return a function as your when you don't count recursion, okay? Because if you okay, it's gonna make sense in a minute, but all right. So let's go make our recursion function. So the first function that we're gonna make is a very popular one called the Fibonacci sequence. I'll just make the file. Alright, so the Fibonacci sequence is just a sequence of numbers where the previous number is equal, the previous number and your current number is equal to the future number. So it starts out like this: 0, 1, 1, 1. These are just like the first 8 digits. Okay. So, we're going to create a function for this. Now, actually, let me explain how Fibonacci sequence works first. So these two numbers, right, are added together to create 1. These two numbers are added together to create 2. These two numbers are added together to create 5. And then 5 and 8 is added together to create 13. So it's the current number and the previous number. If the current number is 5, okay, actually if the current number is 13, what is going to be the future number? If you said 21, that's correct, because 13 plus 8 is 21, and it's the current number subtract plus the previous number. Alright, let's create a function with this recursively. So here what I did is I just defined our function, which is Fibonacci, and I put in the input as n. Okay, so first we're going to start off as if n. Okay, so actually let me first explain what n represents. So n in this case represents the index, which just means where is the function. So in the 0th index, we have 0. It goes 0, 1, 2, 3, 4, 5, 6, 7. I'm sure you learned indexes if you're watching recursion. But yeah. So the first number, which always starts at 0, right? Indexes start at 0, 0. What would be the number at the 5th index? If you said 5, that's correct, because it goes 0, 1, 2, 3, 4, 5. Alright, so that is what n represents. N is just the index. Now, if we notice that if n is smaller or equal to 1, then the numbers don't really change, because it's just going to stay as n. Right? It goes 1, it will just return 1, and then 0 will just return 0. But if it's not equal to 1, let's say 5, and we return which is 5, that's not going to be correct because it's going to be 5 plus 3. It should return 8. Okay. So to do this, we're going to create an if statement. So in a recursive function, you always want to identify your base case first. This just means at what point is the simplest number or the last number of your search. So if I searched for, let's say, 5 numbers, right? And at their index, and if I search for 5 numbers and I'm on the 6th number now, my loop should end, right? And we usually tell this through a for range loop. We say when should the loop end, but we can't really do that in a recursion function, all right? We have to specify that ourselves. But since this goes on infinitely, okay, we don't specify the max limit, we specify the minimum limit, which in this case is when it's one of these values. This is just the simplest case. That's all the base case is. All you have to understand is the simplest case. Okay, but what would happen if it's not, if the index is not greater or equal to 1, right? So if the index is not 1 or it's not 0. Please note that this doesn't mean if the number is greater or equal to 1, because if you said the number is greater or equal to 1, this number, the one right here, would mean that it was also returned to 1, which is not true, because you had the previous number and it becomes 2. Alright, so if that doesn't work, then we're going to create our else clause, and we're going to return the Fibonacci where n is subtract 1. Okay, that just means the previous index, because we go by indexes, not numbers, plus Fibonacci and subtract 2. Okay, so we start at index 5. What we do is we subtract the index previous, which is 3, and then the one 2 before. So 3 plus 2 is 5, that's where it is. If we do at index 8, right, we do 8, subtract 1, which in this case is 7, plus 8, subtract 2, which is 6. 7 plus 6 is 13. It's fairly simple. Now, we can also use this in our search. Actually, let me run it first just to show you that works. So I'm just going to call the function. And in this case, I'm going to give a value that we read another value of, which is 5. If we run this, this should return us 5. Oh, we actually have to print this value too. And it returns 5, meaning it works. If we said 8, it says 21. Alright, so yeah, that's how you do the Fibonacci. And then let's do summing, but with the search. Okay, so it's very common to use for loops and iterations to search through a list or string or any sort of data structure. So what if we had a function that searches through a string recursively, and then it tells us, it could tell us if this character in the string is true, right? We're going to have a string, let's say it's this, and we are going to search for the letter X. X, in this case, is not going to pop up because it's not in the string. If you search for A, which is the first letter, it's going to pop up. Let's create our function. we're going to pass in three parameters, right? We're going to pass in first, obviously, our word. This is going to be the string that we're searching for the character in. We're going to also pass in our character, okay, which is what we're searching for in the word. And we're also going to pass in our index. Our index, just like before, is just the value where it holds, okay? So index 1 here is S, index 0 is A. Alright, and I'm going to just assign it in the parameters. Okay, so the first thing we're going to do is we're going to specify our base case. This is the perfect scenario where base cases are understandable. Okay, so let's say I have a string, and the word in this case is going to be guitar. Okay, so the length of guitar is 6 letters. What would happen if our index was greater than the length of the string? So we would first search through guitar. First search through G. If G is not a character, we search for U. If I is not a character, if U is not a character, we search for I. If I is not a character, we search for T, and so on and so forth. When we finally get to R, if R is not a character, what do we search for? We go on to the next one. There isn't any next character. So this is when we have to specify our base case and tell the function when it ends. So in this case, the function ends at when the last index is searched through. So to do this, we are going to take, this is going to be our example guitar. And we're going to search if the index is greater than the length of the word, -1. So if our index is, in this case, guitar has 6 letters. If our index, which in this case R is F5, is greater than the length of the words -1, which is 5, the reason I added the -1 is because indexes are usually less than the amount of characters they're in. Because the first character is G, but the index is at 0, so we subtract 1. If that makes sense. Okay. And we return false, because if the index is greater than 5, if it's 6, then we've searched through far, and it's going to give us an error, and we want it to end without an error. Alright, so the next step is to search if the character is in the list. Well, it's just to search through it. So first, I'm going to make sure that the character is not the one we're on right now, or if it is. Okay, so here what happened is if the word at the index equals character, return true. So if the word, in this case we're going to use guitar, is at the index, here let's make our character that we're trying to search for T. If the word at index 3 is equal to T, then we return true. Okay. And the way we search through this is just by looping through the indexes. So in this case, we found our character in our string, but what if we don't find it? What do we do then? Right? So it starts at 0, and we search for G. It's not it. Okay, it's not it. The word of the index at 0, right? Because you have index starts at 0. The index starts at 0. It's not equal to the character that we're looking for. Well, then we have to increase the index, right? We have to move through. Because if index is 1, we search the next one. If index is 2, we search the next one. To do this, try it out. We use recursion, and we do index plus equal 1. Okay. We actually we don't have to do plus equal because the index value is already saved. So else we do. I'm just going to print the index just to keep track, and then we're going to return the search. Okay, and we're going to return every single parameter that we have. We return word, the character, and we also return the index. But if we're trying to search through and we're trying to increase the index every time so we can search through every single letter in the string, we have to add a value to it. We wouldn't add 2 because that would skip through U. That would also skip through T, and that would skip through R. Okay, so we're going to do +1. That's it. That's how you just recursively searched. Let's run this, and we'll see if it works. In this case, our word is going to be, make it James. Our character is going to be, oh yeah, we should put in this. Character is going to be, let's make it G. And our index is our index. Okay. So, oh, we should also print true. We should print the, yeah. So it's false. This is because it went past the index of 4, which is 5. So it went past there, it's going to return false. If I made this S, it returns true because it goes to the third index, reaches 4, returns true. Alright, so that was the lesson for recursion. Please like and subscribe, and if you have any questions, you can leave them at the comments and I'll be sure to answer them. Thank you for watching.